13.6 probability. To find the probability of an event, you write the number of favorable outcomes, or what you're finding the probability of, over the number of possible outcomes, so the total things that could happen. We are going to just deal with fractions of probability. There's also probabilities that are decimals or percentages, so you just change the fractions to those things, but we are just going to deal with actual fractions. So for probability today, I'm going to concentrate on rolling a number cube to get this done. So for this number cube, okay, you don't have to draw that. It is the capital P means probability, and then you say probability of, and then whatever's in parentheses is what you want to find the probability of. So the first one, the probability of rolling a 1, so you look at your number cube, how many ones are on that die? 1. And how many possible rolls, how many sides are on that die? 6. So this is just like you learned probably a few years ago, probability 1/6 of getting a 1. But you know, you're in 8th grade, they're going to add some things. So like number 2, the second example, the probability of rolling a 2 or a 3 on a single die. Well, how many 2s or 3s are there on that die? 2, and it's still out of 6, but you must reduce it if you can. So 1/3. Probability of rolling an even. How many evens are on that die? 3, 2, 4, and 6. So 3 over 6. So the probability of rolling an even, 1/2. Okay, now they're getting a little more complicated. So this isn't your typical that you've learned before. Probability of rolling a composite number. So that means you got to know what a composite number is. And it tells you right there. Composite is kind of the opposite of prime. Composite is a number that has more than 2 factors. A prime number has exactly 2 factors, one in itself. And just to clarify so that you know, 0 and 1, you probably ought to write this down, 0 and 1 are not prime or composite, because the definition of prime is exactly 2 factors, and 0 and 1 don't have exactly 2 factors. And they're not composite either. They don't have multiple factors. So 0 and 1 are neither. Composite has more than 2. So think of numbers on a die. How many of those? So how many composites are on that number cube? We know it's not going to be 1. Is 2 prime or composite? Does it have more than 2 factors? Huh? 2 is prime. What about 3? Prime. What about 4? It's composite because it's got 1, 2, and 4 that can go into 4. So there's 1. What about 5? Prime. What about 6? Composite. So we had 2 of them that were composite out of 6, so 1/3. Okay, perfect square. The possibility of rolling a perfect square. Let's think about the list of perfect squares. We've done this before. So perfect square is a number that square root is a whole number, no decimal. So we'll kind of make our list. What's the first perfect square? What's the lowest one? 1. Let's make a list. So 1, and then 1 squared is 1, or 1 squared is 1. So the next perfect square is 4. What's the next perfect square? 9. Next, Brady? Brady, what's the next perfect square after 9? No. Michaela? 16. Somebody tell Brady how we got 16 quickly. 4 times 4. So Brady, what's the next one? 16. What's after 16?
38. What are you talking? I don't get it.
Morgan, what's the next one?
25.
25. Morgan, tell Brady how you got 25.
5 times 5 equals 25.
Okay, Brady, what's the next one? What's the next one? So what is it? 36. Brady, what's the next one?
49.
Thank you. Give me one more.
8 times 8. 69.
64. Okay, so that's the beginning of a list of perfect squares. We don't need that for a die, but you might need it for another question. So how many of those perfect squares could come up on the roll of a die? 2. 1 and 4. So 2 out of 6, 1/3. Okay, and then probability of greater than 6. How many sides are greater than 6?
0.
0. So 0 out of 6. Don't leave it like that because 0 divided by anything is always, you have a probability of 0 of getting something greater than 6. Okay? Greater than 6 does not include 6, by the way. So when they say less than a number, it doesn't include that number. Or greater than a number, it doesn't include that number. Right, unless they say equals 2. Okay, I want to show you one more quick thing. Can I erase the red? Let's say that we did this experiment where we actually rolled a die, okay? So I'm going to make a really quick chart, if you want to do it, and a frequency table. So there's my 1. I rolled 2, 3, 4, 5, and 6, okay? And I'm going to do a frequency. Let's say that I rolled the die, and I'm going to roll it 10 times, okay? And let's say I rolled 1, a couple of times, so I got 2 tallies for 2. I rolled a 2 only once. I rolled a 3 only once. I rolled a 4 3 times. And then a 5 once. And a 6 twice. So I had a total of 10 rolls. Okay? Now, let's say that I use this experiment to help me figure out if I had similar results, how many times would I get a 4 if I rolled 200 times?
200 times out.
Okay, how many times would I get a 4? If I use my results from my experiment, how many times would I get a 4 if I rolled 200 times? You need to set up a proportion. So here's my proportion. Out of 10 times, how many times did I get the 4? 3. I'm going to roll it 200 times, and I want to know how many times you think I would get it.
Times 2, 820.
Yep, cross, cross. So 3 times 200 is 600. And 10 times x is 10x. Divide by 10. And I should expect to get a 4 how many times? 60 times. That is using results from an experiment. Okay, you're going to set up a proportion. It's not exact probability. Are there any questions on that?